we are working this week on joint or point or particle in equilibrium. Equilibrium means all horizontal component, summation of all horizontal component equals 0. Summation of all vertical component equals 0. Why equals 0? Because this particle is in equilibrium. In equilibrium means no movement, right or left, or up or down. If you have any number of forces, whatever do you have, go ahead and get the horizontal and vertical component for each force. Then summation of all horizontal component equals 0, all vertical component equals 0, if only this particle in equilibrium. And we solved few examples last meetings. Let me start with example number 5. We have a lamp with weight 20 kilogram. Also, I told you last time, I believe, weight for anybody will be vertically down. Any weight for anything. This weight probably in pound or Newton. Probably in kib or kilonewton. Kib is 1,000 pound. Kilonewton is 1,000 Newton. Whatever. These units for SI units, these units for US unit. We don't care about, but we need to learn that the weight should be one of them. But if the weight is given in kilogram, we need to multiply it by acceleration of gravity, 9.81 meter per second square. So if you multiply kilogram by meter per second square, you can get your value in Newton. So we have here lamp with 20 kilogram. So the on weight of this lamp is down. How much? 20 kilogram. I need to multiply 20 by 9.81. So the final weight in Newton will be 20 times 9.81 will be 196.1 Newton. This lamp is supported by 1, 2, 3, 4 cables or cords. Cord AC, CB, CD, DE. So if you are looking for joint D, can you redraw joint D here? We have joint D. Here is joint D. What do you have at joint D? Try to think. What do you have? We have vertical on weight. How much? 196.1 Newton, the weight of the lamp. What do you have else at joint D? I'm talking about joint D. We have cord in this direction, can be called FDE. This one. We have another cord which is horizontal with a force, can be called FDC. Whatever, FDC or CD, I don't care. So we have 3 things connected or intersect at point or particle or this hook which called D. What do you have at point C? We have another point here called C. So here is point C. One by one, step by step. We have at C, this chord will be called F, C, D, or DC, I don't care. We have one in this direction, which called F, C, B, or BC. We have another one here, F, AC, or CA. Do you agree with me? Any questions so far? This system, whatever, we have more points like C and D, we have more. Okay, go ahead and try to draw something I told you last time, which called free body diagram. Free body diagram means you have a system, you have something in the real life, like you are seeing this system to support this lamp. I will convert this system in the real life to something related to engineering mechanics. What are the forces do you have? This called free body diagram. So for joint D, we have 3 chords. The first one vertically down, which is the weight of the lamp. The second one, this chord. The third one, this chord. For point C, we have 3 chords, the horizontal one, and this one, and this one. Any questions so far? Okay. These 3 forces are in equilibrium. So we have problem. These 3 forces are in equilibrium. So we have another problem. Can you remember the first example I solved? Do you remember this one? Or this one? So we have 2 problems. The first one, we have 3 forces in equilibrium at joint D. For second one, we have 3 forces are in equilibrium at joint C. My question is, please pay attention, and I need answer from you. Guys, I will need answer from you, and I have some reward for the first answer. Which joint I will start? Do you think I will start with C, or I need to start with D, or it doesn't matter? We have 2 problems right now. We have 2 joints. Both of them are in equilibrium. Do you think I will start with D or with C? What do you think? D. D. Any other answer? Why D? Why D? Do you know why D? And the other opinion, why C? If you have a different opinion. Okay, my question is, Niraj Karki is the same like Niraj, is it the same account? I have 2 Niraj, I think. Anyway, okay, thank you, John. So Niraj and Aaron and John will have extra 3 points in the coming exam. Niraj, Aaron, and John Miller will have extra 3 points for the coming exam. But I cannot, I think it's Niraj Karki. We have another Niraj, probably. Niraj, or Kate, Tiwada. Anyway, so all of these students will have extra 3 points in the coming exam. Yes, guys, I will start with the joint with least number of unknowns. I will start with the joint or with the particle with least number of unknowns. My question is, if DE is unknown, if DC is unknown, but this weight is known, so we have 2 unknowns. For particle C, if DC is unknown, I don't know what is the value. If CB is unknown, if AC is unknown, so we have 3 unknowns. I will start with the least number of unknowns. So I'm gonna start with D. So I will say for particle D, particle D, we have vertical weight 196.1. We have a force here, FDE, I think. We have a force here, FDC. This angle is 30. So let's go. First force, this force, FDE, has 2 components, one horizontal with this angle theta equals 30 and one vertical. So I believe the horizontal component will be FDE cosine 30. The vertical component will be FDE sine 30. Nothing else, because the vertical force is vertical. We don't have horizontal. The horizontal force, FDC, is horizontal. We don't have vertical component. So if you apply summation f of x equals 0, what do you have in x direction? We have this component, which is positive. FDE cosine 30. What else? We have this one negative. Be careful about the sign. Negative FDC. Do you have anything else? Please don't forget any. I'm talking about only joint or particle D. I don't care about anything else in the problem. Go back to the original problem. Once you did your free body diagram for joint D, here you go, and the free body diagram for joint C, here you go. Both of them are different. We have 2 problems right now. So I'm talking about this side, which is particle D. So we have horizontal component, this one, and this one. That's it, equals 0. I think we have 2 unknowns, FDE, FDC. I cannot do anything. This is problem number 1. Second equation, summation of all vertical component equals 0. What do you have in vertical direction? We have this component, which is positive, FDE sine 30. What else? We don't have vertical component here. We have vertical component here, which is negative. 196.1 equals 0. I believe I can do something with this equation because I have only one unknown, which is FDE. FDE, if I move this number to the other side, will be positive. 196.1 divide sine 30. So your value will be 392.2 Newton. I believe I can go back with FDE to put it here in this equation. So I can say 392.2, which is FDE cosine 30 minus FDC equals 0. Move FDC to the other side will be positive. So FDC will be 339.6 Newton. I am done with joint or particle D. But remember, FDC equal 339.6. So FDC equal 339.6. This force FDC is the same like this force FDC or CD, whatever, 339.6, because you are talking about the same chord. This chord is one chord, the same. From this side must equal the value from the other side, because you are talking about the same chord. So right now, I'm going to walk, or I'm going to solve particle C. So I will say for particle C. What do you have at C? We have horizontal force here, which called FCD or DC, which is 339.6. We have force here. Sorry. We have force here, and we have another force here. You go back, FAC and FCB. So FAC and FCB. This force in this chord has right angle triangle 3, 4, and 5. We have here 3, 4, 5. And for the second one, we have angle here 45 degree. This one, 45 degree. So go ahead and break these forces to two components, each one. Let's start with the force FAC. We have right angle triangle 3, 4, 5. We are looking for horizontal component and vertical component. Do you remember what was the sequence? Yes, I need to select an angle, whatever, this one or the other one. So I will select this one, theta. I believe this one equal to this one. We have this line and we have another line in the triangle. So we have this intersection. So this angle equal to this one. So the horizontal component will be FAC cosine theta. The vertical component will be FAC sine theta. Remember, from this triangle, based on your selection of theta, which is equal to this one, 3, 4, and 5. So sine theta equal 4/5. Cosine theta equal 3/5. Guys, remember, don't do the same mistake. Cosine theta as a whole term is 3/5. Sine theta as a whole term equal 4/5. What else? We have this force FCB. We are looking for horizontal and vertical component. I believe this angle will be 45 degrees by Z shape. So it will be this direction FCB cosine 45, and this direction will be FCB sine 45. Regarding this force, it's only horizontal component. We don't have vertical component. Go ahead and apply summation f of x equals 0. What do you have in x? We have this component which is negative 3/5 FAC. What else? We have this component, this one, which is positive 339.6. What else? We have this component which is negative, don't forget any, negative FCB cosine 45 degree, nothing else, equals 0. This equation has two unknowns, FCB, FAC. So forget it right now. Go ahead and apply summation of all y component equals 0. What do you have in y? We have this component which is positive 4/5 FAC. What else? We have this vertical component which is negative FCB sine 45 degree. What else? We don't have vertical component here, it's 0. So all of these equal 0. Actually, we have two equations for two unknowns. We can simplify the first one, negative 0.6 FAC, negative 0.71 FCB equal negative 339.6. I moved this term, which is positive, to the other side will be negative. If you simplify this one, so 0.8 FAC, negative 0.71 FCB equal 0. Solve this equation. With this equation, I can figure out the value of FAC and the value of FCB. I will solve these equations. Just a second. Negative 0.6, negative 0.71, and negative 339.6, 0.8, negative 0.71, and 0. So this one will be 242.6. This one will be 273.3 Newton and Newton. So finally, I am done with all the required forces. I figured out what is the value of FAC, what is the value of FCB, what is the value of FDC, which is the same from this side or this side, and what is the value of FDE, because we are looking for the tension developed in each chord. We have 1, 2, 3, 4 chords. So we have 4 forces, FDE, FCD, FBC, and FAC, and I am done. Any question? Guys, any question? Okay. The third or the fourth one in your homework, this one. We have a bucket with weight vertically 50 pounds. Okay, 50 pounds. Guys, one more time. We have a mistake here in problem number, which one? Yeah, problem number 3. Is it 50 or 30? No, it's 50. Okay, it's 50, not 30. Okay. We have here a bucket with 50 pounds. So we didn't need to multiply anything by anything. just only if this weight is given in kilogram. So we need to multiply by 9.81 to convert it to Newton. So what do we have for joint E? Here is joint E. We have vertical weight, 50 pounds. We have this force, which called FED, and this force, which called FEB. This one is given with angle. This one was given with right angle triangle. What do you have else? Joint B. We have this force, which is F also CB. I'm sorry. Force BE or EB, whatever. This force FBC and this horizontal force FBE. So we have two problems or two joint in equilibrium. Which one I will start? You have to ask yourself this question. Do you think I will start with this one or start with this one? I need to start with the particle with the least number of unknowns. We have here, this one is unknown, this one is unknown, this one is known, so we have two unknowns. We have here three unknowns. This one is unknown, this one is unknown, this one is unknown, so we have three unknowns. So I'm gonna start with this particle, apply summation f of x equals 0, summation f of y equals 0, and get your values. Remember, this force, which you called FEB, will be the same like this one, FBE. Both of them the same chord. This one is called BE or EB, the same. Then go ahead and apply summation f of x equals 0 for this particle and apply summation f of y equal 0. Someone will ask me a good question. You told us to start with the least number of unknowns. What will happen if I started with this one first? You will not get anything. You will set up your equation and you have many unknowns and less equation. You cannot solve to get your unknowns. So you have to wait for this one. So I'm advising you to start with this one to get numbers, to get results. Then go ahead to solve for the other one to get the remaining forces. Okay. The same also for this one. We have two particles, B and C. The same also for this one. We have two particles, this one and this one. Okay. And this one is very easy to solve. I believe your quiz, something looks like the same, like something looks like this one. Okay. So any question? No. Okay, one more time. Guys, if you go back to the first week, the first meeting, we have two kind of units, SI and US. Your force can be in Newton or kilonewton. In US, your force can be in pound or kib. So if you see your force in pound or kib, that's fine. We don't need to convert anything. If you see your force in Newton and the kilonewton, that's fine. We don't need to convert anything. The only issue, if your force or weight is given in kilogram, the only issue in one case, one condition, if the force or weight is given in kilogram. If you see kilogram in any problem, you have to multiply it by 9.81 to convert it to Newton. Anything else, you don't need to convert anything. Okay, perfect. We have one more example. Very easy. We have a weight. Your question. Gilberto, your question. We have a weight here at blocks at B and C both of them, each of them weight 500 pounds. I don't need to convert anything because the weight is given in pound. Pound is good. So at B, this weight equal 500 pounds. That's fine. At C, we have the same weight with the same number, 500 pounds. Determine the weight of block D. What is the weight here? Is unknown. And the angle theta. What is the angle theta here? Is unknown. To keep equilibrium. To keep equilibrium. Can you watch this connection, please? What is the name of this connection? It's called valley. It's written like this, I think. Yeah. What does it mean? We have a valley and we have rope or cable around this valley. If you apply a force here equal 50, we have another force in the opposite direction here must be 50. If you apply a force here W, you have another force here W. So if you have a valley like this and we have weight here equal 500, and this valley we have a rod or rope like this, so this force must be also 500. So at this one, this rope has a weight equal 500. That means this rope around this valley must have here 500. This one has a weight 500, and this one rotate about this valley, so we have here also 500 pound. If you go back to the previous problem, if you are talking about the same cord or the same rope, from this side we have a force, from the other side we have a force, the same value but in opposite direction. Can you watch? This force FDC and this force FDC, the same value but in opposite direction. What does it mean? We have here a force in the opposite direction 500. We have also a force here opposite to this direction will be 500. So finally, joint A or particle A has vertical weight, I don't know, has a force here in this chord 500, has another force here in this chord 500, and this angle is unknown theta, and this angle is given 30, so I can do equilibrium. I will explain this one more time. I will go through this one more time. We have two concepts here. We have two concepts in this problem. The first concept, okay, thank you, John. It's Pulley, not volley. Okay. The first one, the first concept, if you have a pulley and you have rope around this pulley, So the force on this side must equal the force on the other side. The problem said we have 500 weight at B. That means the force on this rope or cord on the other side will be 500. We can go to the other pulley. So we have weight here, which is weight at C equal 500 pound. That means the weight in this cord will be 500 pound also. This is the first concept. The second one, if you are talking about the same rod, the same rope or the same cord, this cord will have a force here, 500, will be also the same value but in opposite direction on the other side. So I can expect here another force, same value but in opposite direction for this one. For this cord, because we have the same cord, so we can expect the same value of force 500 but in opposite direction 500. So finally, I can go through particle A. We have vertical weight here. This weight is unknown. We are looking for the weight of block D. And this force is known 500 with angle 30. This force is known 500 with angle theta is unknown. That's it. This particle A is in equilibrium. So I can apply summation f of x equals 0 and summation f of y equals 0. One by one, go ahead and get the horizontal and vertical component of this force, horizontal and vertical component of this force, horizontal and vertical component of this weight or this force, and then go ahead and apply summation f of x equals 0, summation f of y equals 0. We have two equations, we have two unknowns. I can solve them together to figure out what is the value of this weight, what is the value of this angle theta. Okay, thank you, John. It's called Pulley, not volley. I'm sorry. Okay. Any question? Any question? So we can expect two problems right until now in the exam. The first one, on the first week, we have system of forces. We need to look, we are looking for what is the resultant force, or sometimes the resultant force is given, so we can look for different things. The second module in week number 2, we have a system of forces are in equilibrium. In equilibrium means joint or particle in equilibrium means summation of all horizontal component equal 0, summation of all vertical component are equal 0. We have homework with 4 problems. The due date is September 7 at 10 a.m.